My third video in my module on proving trig identities, and in this video we're going to focus on looking at identities where possibly like adding or subtracting fractions is not an option. We're not going to factor, we're not going to distribute, no monomial divisors. What we're dealing with is something that if all else fails, you convert to sines and cosines. So let's take a look at this first identity up here on the left. Let's decide first of all what side we want to work on. I'm going to go ahead and opt to work on the left side here, and just for the simple reason that there's a sum, not that I have to work with a sum or a difference, but it tends to be easier to work with for me. So taking a look at tangent and cotangent, if I wanted to add these two things together, I don't see anything squared, so there's no Pythagorean substitutions I can do, but I can rewrite tangent as a sine of x over cosine of x, and this would be sine over x, sine over cosine, each of x, plus cosine of x over the sine of x, okay? So now I'm working with something where I would actually be adding two fractions together. And recall that when you add two fractions together, the common denominator is the product of the two denominators. It may not be the least one, but it is the product. So we say sine times sine in this case would give us a sine squared of x here, plus cosine times this cosine would be cosine squared of x. Cool. Okay, so I say cool because this right here I recognize as being our Pythagorean identity, because sine squared plus cosine squared always equals 1. We can now rewrite this as 1 over cosine of x times the sine of x. And so recall that I am trying to prove that it equals this right side right here. And keeping that in mind, how is it that I'm supposed to show that a 1 over cosine times 1 over sine is secant times cosecant? Well, recall that secant here is 1 over cosine itself, and that cosecant is 1 over sine itself. And so if I'm trying to show that these two things are equal, then I really kind of already have. But I guess what we can do here is this. Whenever you have like a monomial numerator and a product of many things in the bottom, you can rewrite this as the product of many different fractions. So we say 1 over cosine times 1 over sine. And that would be the same thing as the secant of x times the cosecant of x, which is what we wanted to show. We wanted to show the left-hand side is actually equal to the right-hand side. Cool. So on to the next one here. It's kind of a similar situation, but we say let's prove that cosecant of x minus sine of x equals cosine x cotangent of x, okay? So possibly, I don't know, what if we tried to work on the right-hand side first? I mean, this is not a crime. I mentioned that we'd work with a sum or a difference, be a little bit easier, but let's go ahead and take a look at the right-hand side. At least in terms of what I can do, I don't see anything squared, so I can't do any Pythagorean substitutions. I also don't see anything I can distribute, factor, add, or subtract fractions, so we're just going to go ahead and try rewriting this in terms of sines and cosines and see if that's helpful at all. So we get cosine of x is cosine of x, and then cotangent of x is the same thing as cosine of x over the sine of x. Okay, so perhaps, I don't know, why don't we go ahead and multiply these? I notice that nothing cancels. I get cosine squared x on the top, and this is over sine of x. Okay, so now I'm trying to show that this equals the left-hand side. Fact is, I could do a Pythagorean substitution on the top. Of course, we know that the cosine squared of an angle is equal to 1 minus the sine squared of an angle. But I think at this point we say that wouldn't be very helpful to substitute that in yet. Okay, so let's take a look at the left-hand side. Let's say I'd work with the left-hand side. We can work on both sides, just not at the same time. So now, displacing the left-hand side to be down here, we could say, well, cosecant. Maybe we rewrite this as 1 over sine of x. 1 over sine of x. And this is minus the sine of x, and we could put the sine of x over 1 and say, well, then what would our common denominator be? And of course, again, it'd be the product of these two things. So our common denominator on the left-hand side is sine of x times 1. So we get sine of x downstairs. We still need to do this. We take this 1 times this guy's denominator. We get 1. Now minus. Now sine times sine. This would be sine squared of x. So now we're trying to show that this equals this right here, but if you haven't seen it yet, hey, it's just this identity we listed over here. 1 minus sine squared of x is indeed the same thing as the cosine squared of x because of our Pythagorean substitution abilities. So working with this, we could say, well, cosine squared of x over sine of x is the same thing as what I was able to establish over here. So what I want to bring up is you can work on both sides, just not at the same time. But if you can get the left-hand side to say all the way down to here and you get stuck, and you get the right-hand side to end up with the same thing, if this is equal to this, then what you've really done is you've built a bridge all the way around from one side to the other, okay? And doing so actually shows that we have proved that the left-hand side and the right-hand sides indeed are equal. Cheers.